Okay, so in this video, we're going to practice transformations of the cotangent graph. Very similar to what we did before, but we're going to do bx minus c equals 0, bx minus c equals pi, because remember, the cotangent graph is just shifted to the right, 0 and pi, and it's like a reflected tangent curve, goes the opposite direction. So that's where we're starting from as we do these transformations instead. Okay, so number one just has an a value of 2/3. That means b is 1, c is 0, d is 0. So it's not too bad, which is really nice because the whole bx minus c thing means my asymptotes are staying the same. So it's going to start at 0 and it's going to end at pi. Easy enough, right? The period would still be pi over b, which b is 1, so it's just pi. Vertical asymptotes will fall where we can start at 0. We can do that. That's fine. Where x is 0 plus n pi, and ultimately you don't have to do the 0. So that means my domain is all reals except where x equals n pi. And then the range, as always, is negative infinity to positive infinity. Okay, so maybe we should graph this thing. We know there's an asymptote at 0. And I'm just going to take 4 tick marks to get to pi. You don't have to, but just label. And right in the center. Now, a is 2/3, which means it's not going to be as steep. It's going to flatten out a little bit and still get close to the asymptote. So it's going to be flatter. It's hard to draw, but that's what the a value is doing. Okay, so there's that one. Let's try the next one. This one is cotangent of x over 4. So you can think of it as 1/4 x. So let's think. A is 1, B is 1/4, C is 0, D is 0. So it's going to change our asymptotes. So let's do that. 1/4 x equals negative pi over, oh, sorry, that's not correct, is it? It's 0. It should be 0 for cotangent. All right, well, that's an easy enough one to solve. That means that if I multiply by 4, x is still 0, right? 1/4 x is equal to pi. So I'm going to multiply both sides by 4, and I get 4 pi. So the period's going to start at 0, and it's going to end at 4 pi. So let's go ahead and graph it. If I do each tick mark as a pi, just label. You can take more than those tick marks. A is just 1, so it's not reflected. Just remember, the cotangent goes like in a negative slope, okay? All right, let's fill in our gaps here. Let's see, range is negative infinity to positive infinity. The period is pi over 1 over 4. So you can see this in the graph that the period is 4 pi. So if I keep it, change it, flip it, I would end up with the period of 4 pi. Vertical asymptotes, okay, let's see. You can say 0 plus 4n pi is how we would write it, 4n pi. So the domain is all reals except where x is equal to 4n pi. Let's try the third one. Notice that a is negative 1 and b is 3. Okay, so that's going to change our direction, right? The bx, or the 3x, let's just do this. So 3x equals 0, so that brings that left asymptote is still at 0. 3x equals pi, so I have to divide by 3. So the other asymptote will be at pi over 3. So this is 0. I'm just going to take 3 tick marks for funsies. Pi over 3. Pick in the middle. And since it's negative, that means instead of having the normal negative slope of the cotangent, it's just going to reflect and become the positive slope. Okay, my range has not changed. The period is going to be pi over 3, which is very visible right here. You can see that. Vertical asymptotes, okay, 0 plus n pi over 3s, right? So you can just say n pi over 3 is fine. You don't have to write the 0. So we can do all reals except where x is equal to n pi over 3. Let's try the next couple. Or next 3, I should say. Okay. So a is 1. Here's our bx minus c stuff, right? There is no d, so let's just do the work. Okay, so x plus pi over 2 equals 0 means that that asymptote is going to be negative pi over 2 when I move it over. And then x plus pi over 2 equals positive pi. If I subtract half a pi, that leaves me with half a pi. Okay? So it's shifting our graph. Think about this. It's shifting it to the left, isn't it? So I'm going to do pi over 2. And I'm going to do negative pi over 2. And then there's my vertex point. A is a positive one, so it's going to maintain the same direction as the original parent function of cotangent. Okay, so range, negative pi, positive, negative infinity to positive infinity. Asymptotes will be negative pi over 2, positive pi over 2. Okay, if you look at our period, half and a half makes a whole, but you can do it by formula if you want, if you recognize that b is 1, so pi over 1 is pi. Vertical asymptotes, I'm going to take pi over 2 and add n pi's. Remember, our period dictates that, and then this dictates our domain. We would say all reals except where x is equal to pi over 2 plus n pi. Let's keep on going. This one has an a value of 1/2, so it's going to be a little flattened out, not as steep in the curvature. And let's look at our bx minus c. So it's x minus a fourth equals 0. So when I solve that, it's just going to become a positive 1/4. X minus a fourth equals pi. So if I add a fourth, mental math, it's going to be 5 pi over 4. Okay, so where does it start? At pi over 4. Where does it end? At 5 pi over 4. What's the difference? Well, the difference between them is 4 pi over 4 or pi. You could do it by hand, just do pi over b. B is just 1 in this scenario. Range is negative infinity to positive infinity. Vertical asymptotes. We could take either one of these is positive. I'm just going to take the smaller. Pi over 4 plus n pi's. And then we can do all reals except where x is pi over 4 plus n pi. So I guess I should graph this guy. Okay, so if I do pi over 4 marks, 2, 3, 4, 5. Okay, find the center for the vertex. Now the 1/2 is just going to mean it's going to flatten out a little bit. Oops, wrong direction, isn't it? Sorry. It's going to flatten out. That's all that a value is going to do. Okay, last one. Feel free to pause the video, try this one on your own, and come back and see how you did. I will want to point out, though, look at A. A is negative, and it's 2. B is 1. Now notice there is no C value because there's no parentheses. So C is 0. This negative 3 is actually D. So my vertex is going to move down 3 when we go to graph. So look, if we do bx minus c, that's like 1x minus 0 equals our left-hand asymptote. 1x minus 0 equals the right-hand asymptote. So this is an easy one, right? So our asymptotes didn't move from the original parent function. Yay, that makes it nice. So I'm just going to call pi over here. That's dotted. Okay, so here's my vertex originally right here, right? But it moving down 3. 1, 2, 3. And it's reflecting. So what normally has that negative slope is now going to have a positive, and it's 2. So it's going to pull away from those asymptotes right there. Okay. Now let's finish this up. Okay, a range is negative infinity to positive infinity. That's always the case. Our period is just pi. Vertical asymptotes are going to be where 0 plus n pi, and domain would then be all reals except where x equals n pi. So not too bad at all. Hopefully you're understanding. Please let me know what questions you have.